Okay, so the next thing that we're going to look at are some of the acid derivatives. It's an acid derivative because they're made from carboxylic acids. You don't need to know that much more about them, but there's two key ones that we're expected to know about other than esters. And in essence, that Z group can be replaced by two things. Either it can be replaced by a Cl, in which case I've got an acyl chloride, or it could be replaced with an O and another C double bond O R group, in which case I've got something called an acid anhydride. If I was to show an acyl chloride in a structural formula, I'd write it as RCOCl, so the C double bond O, and then also bonded to a chlorine. With an acid anhydride, however, it can be written in a few ways. What you'll notice if I draw it like this instead is that actually what you have is pretty much a symmetrical molecule. Sorry, that's an R. So on each side of this oxygen, I have a C double bond O and an R group, and those R groups will be the same, or at least what we need to know is that they are the same. So if I want to show bonded to this oxygen are two same sets, I'll have an RC double bond O, put that in brackets, I have two sets of it, and they're bonded directly to an oxygen. So I have an RCO, two of them, because I have one on this side, one on this side, directly bonded to an oxygen. Alternatively, I don't know why I rubbed that out. Alternatively, I could write this out as it reads. So I could write R C O O C O R. The reason I kind of avoid writing it like this sometimes is because you can get confused with the number of oxygens and carbons, etc. or write them in the wrong orders. So for me, this is just a little bit clearer. But you do have to be able to identify an acid anhydride as either one of those two in terms of a structural formula. So an RCOCl for an acyl chloride and this for an acid anhydride. Like I said, we anticipate for an acid anhydride that those two R groups are the same. So if, for example, I had CH3, C double bond O, O, no, and a CH3, I've got my same R groups on either side, so I could write this as a CH3, CO, which is this. I've now got two of them, because I've got one over here as well, sorry it's moving. Put that in brackets, and then that final oxygen on the outside. Alternatively, I could write CH3, CO, once again, this section. Then I have another oxygen, then I have a CO, and then a CH3. It's up to you how you want to write it, but you just have to be able to identify that both of those are acid anhydrides. So that's kind of just it with regards to their structural formula. The next thing is going to be looking at naming our acyl chlorides and our acid anhydrides. Sometimes you might see this as an acid chloride. That's completely fine, it's the same thing. So when we name an acyl chloride, let's just split it like this. When we name an acyl chloride, we end it with our naming of noyl chloride. Oh no. Sorry, oil chloride. So, for example, if I had something that looked like this, that carbon is my highest priority carbon because it's carbon 1. So the longest carbon chain is 1. So I'd have a methane, just to identify it's that part. And then an oil chloride because it's the C double bond O Cl. If I had this, my longest carbon chain, with that being carbon 1, is 1, 2. So I have an ethane, and then once again CO to Cl, ethane, oil, chloride. We could take it one step further because I'm just a little bit awkward. we could have something that looks a little bit like this, in which case we still follow our same naming principle. I have a C double bond OCl, so that's my carbon 1. So I could go 1, 2, 3. Alternatively, I could go 1, 2, 3. But I have a prop as my longest carbon chain, sorry. It's an oil chloride, so it's an acyl chloride. That's two separate words, just note that. But now what I've done is I've done all of this section. I'm still left with a CH3 over here. That's carbon 1, so therefore carbon 2. I've got a 2-methyl propanoyl chloride. Same principle. Find your longest carbon chain where you've got this as your carbon 1, because that's our highest priority. So I've got 1, 2, 3, 4, 5. So I have a pentam. It's clearly an acyl chloride, so I have a pentanoyl chloride. But that's not me fully done, because I also have on that long carbon chain a Cl and a CH3. That's carbon 1, so therefore my chloro is on carbon 4 and my methyl is on carbon 3. Even though the chloro is on carbon 4, I have to put that first, because remember we use our alphabetical order. So I have a 4 chloro, 3 methyl pentanoyl chloride. So that's just the naming of your acyl chlorides. If it was the same thing, the important thing is just remembering what your suffix has to be. So that's naming your acyl chlorides. The final one is naming your acid anhydrides, which is actually quite straightforward. When you have your acid anhydrides, for example this, which was the one that I actually drew out over here, so I'm just going to write it, I'll draw it, sorry, a little bit bigger, up here. An acid anhydride is made up of 2 carboxylic acids. So the carboxylic acid that would have been used to make this has to be the same on both sides. So I can identify my longest carbon chain over here, so 1, 2. So it would have been made up of ethanoic acid. I've also got ethanoic on this side. As I have 2 of them, I've got an ethanoic anhydride. If I had something that looked like this, I've got one side and one side. My longest carbon chain on either side is just 1. So I've got a methanoic anhydride. I could draw this out. In which case, my longest carbon chain on both sides is 3. So I have a propanoic anhydride. It's up to you if you want to try and write out your structural formula for this, but I'm going to give it a go. So I've got my CH3, CH2, CO. I have 2 of them. So therefore I'm going to put a 2 over here, and then I have that final oxygen on the outside. Alternatively, if I want to read all the way across, my CH3, CH2, COO, CO, CH2, CH3. Either one would suffice. But that's just introducing different acyl chlorides, what acyl chlorides are, and acid anhydrides, and how to name them and write their structural formulas.